Today we continue with the series, but we're looking at the March 2022 question paper from the Hubden province. And our first question is asking us to solve for x. In this question, our vectors are going to be it is stated to give our answers to the nearest two decimal places. So from there we know that we are going to use a quadratic formula. First we have to transpose our 10 into this side. For the third one, there are multiple ways to solve this, but the method that we're going to use is using k x to the power 1 over 4. That means that our k squared is going to be x to the power half. So this is k squared plus 3k minus 28 is equal to 0. Our factors are going to be remember, we're not solving for k, so we need to bring back our x to the power 1 over 4. So x to the power 1 over 4 is equal to -7. X to the power 1 over 4 is equal to 4. We don't want x to the power 1 over 4. What we're going to do is exponentiate with to the power 4. So to the power 4, to the power 4. Power 4, this to the power 4. So x on this side is going to be positive 241. This side 256. The first part of this question, we want to get rid of this square root. So we're going to square both sides. Square both sides by 2. Then here we have 2 minus x. Here we're going to have x squared minus 4x plus 4. Take all these to that side. X squared minus 3x plus 2. Our factors are going to be x minus 2, x minus 1, x is equal to 2 and x is equal to 1. But one of our factors is not really going to solve this solution. Our original solution was the square root of 2 minus x is equal to x minus 2. If we substitute 1 here, we're going to get 2 minus 1, 1 minus 2. This is going to be 2 minus 1 being 1. The square root of 1 is 1. On this side, we're going to get 1 minus negative 2, negative 1. So x will not be equal to 1. This question is asking us for which values of k will this equation have real roots. This equation will only have real roots if the change is greater or equal to 0. That being b squared minus 4ac squared is greater or equal to 0. From this equation, we have our a is 3, our c is k, and then our b is kind of very interesting because it's within this one. So here we have kx minus 3x. We have a common factor being x. We're left with k minus 3. This k minus 3 is our b. So here we're going to take k minus 3 squared minus 4 times 3 times negative k, and treat this like an inequality. This is going to be 3. Distributed throughout is going to be positive 12k. Then we have k squared plus 6k plus 9. Our factors are going to be we can also write it as k plus 3 squared, and then we solve for k. The square root k plus 3 still greater than k. We take 3 to the other side. K being greater or equal to negative 3. Values of k that are greater or equal to negative 3 are the values that will allow this equation to have real roots. Simultaneous equation, solving for both y and x at the same time. The first thing we need to do is to look at the easiest looking equation and go for it. This one, we're going to take the first equation and make x the subject of the formula. This is our first equation, this is our second equation. We then substitute 1 into 2. Wherever we see an x in the second equation, we're going to substitute 5 minus 3y. This is going to be 25 minus 15y minus 15y plus 9y squared plus take this to this side. From here, we can use the quadratic equation to find the factors of y. Now we have our factors, we can substitute these, substitute y into our first